Good day. So I'm Engineer Leandro A. McFarland. So I'll be discussing engineering economy. So starting with engineering economy, we have simple interest. So to compute for simple interest, we have the interest to the present amount or principal amount multiplied by the interest rate times the number of interest period. Okay, so all you have to do is supposedly n should be expressed in terms of years. So we have two main types of simple interest. We have the first one. This is the ordinary simple. The ordinary simple interest. For ordinary simple interest, what is the equivalent of 1 year? 1 year is basically equal to 360 days. Okay, that makes it, we have 1 month. So 1 month should be equal to 30 days only. So it doesn't matter if that month is 31 days, or 28 or 29. It is assumed that 1 month is 30 days. Okay? So we have the second type of simple interest. We have the exact. For the exact simple interest, 1 year can be equal to 365 days. This is for non-leap year. Or we have 1 year can be equal to 366 days. This is for a leap year. Okay? So how to compute for the future value? The future value of your money, if you are using simple interest, is your capital or your present amount plus the simple interest. So future amount can be computed as present amount plus interest is PIN, or we can have the future amount is the same as present amount, 1 plus IN. Okay, so these are the equations for simple interest, future amount. So let's have an example. First, ordinary simple interest. Okay, so find the ordinary simple interest of 1,000 pesos for 8 months and 20 days at an interest rate of 10%. We have the present amount is equal to 1,000. A number of interest period, this is 8 months plus 20 days. So let's have it in terms of days. We have the number of interest period, this is 8. So if you are using ordinary simple interest, 1 month is simply equal to or strictly equal to 30 days. So this is 8 times 30 plus 20. We have the number of interest period as 260 days. And the given rate is equal to 10%. So how to compute for the interest? We have I is equal to present amount, interest rate, number of interest period. So we have I is equal to a present amount of 1,000 multiplied by I. You have 0.10, but it's multiplied by 260 days. So again, you need to express n in terms of years or year. This is multiplied by 1 year. For ordinary simple interest is 360 days. Okay, so we have I is equal to this is 1,000 multiplied by 0.10 multiplied by 260 over 360. So we have the interest na equal to 72.22 or 72.222. So we have for the choices, we have letter A. So by the way, I'm using one of the allowed calculator of PRC for board exam. Okay, this is the Canon F-789 SGA. So it is similar to the Casio 570 ES Plus, but Casio 570 ES Plus is not allowed. So I'm using Canon Canon F-789 SGA. So for reason, it has a function of ship solve or the ship count, mod equations, and so on. So the same as the Casio 570 ES Plus. Okay, let's have the next example. Okay, so our next example is an example of exact simple interest. So find the exact simple interest on 1,000 pesos which was deposited on January 8, 1990 to be withdrawn on October 8, 1992 if I is equal to 10%. So for example, sa board exam, if the term exact simple interest was not given or is not given, how do you categorize this problem as exact simple interest? Usually, for exact simple interest, dates are given. Okay? So again, so you need to count the exact number of days. So be careful. Okay, just observe the year. Is it a leap year or a non-leap year? So you need to determine, for example, the number of years we may consider January 8 of 1990 to January 8 of 1992 to be 2 years. We don't need to count the exact number of days. We may use these dates to have a period of exact 2 years. All we have to do now is count the number of days. Okay, count the number of days from January 9 to October 8 of the same year, which is 1992. So, how many days is January 9 up to October 8 of the same year? 1992. So, how to determine if 1992 is a leap year? All you have to do is it divisible by 4? Later, we need to check that. Let us determine the number of days. We have for January, how many days are remaining if we are to neglect up to January 8? So 31 days for January, 31 minus 8, that is equal to 23 days for January. So 1992 is divisible by 4. So this is it divisible by 4? We have 1992 divided by 4. So this is equal to 400. 498, which means 1992 is a leap year. So if it is a leap year, how many days for February? So we have 29 days. How many days for March? We have 31. How many days for April? We have 30. How many days for May? We have 31. Okay, June. We have 30. July. We have 31. August. For August, we have for August the same as 31. September, we have 30 days. Then for October, how many days for October? Since we are until October 8, then we have only 8 days for October. So we having the number of days. Okay, how many days from January 9 to October 8 of 1992? So we have, this is 23 plus 29 plus 31 plus 30 plus 31 plus 30 plus 31. So we have a total of 274 days. Okay? So from January 9 to October 8 of 1992, a total of 274 days. So again, this is exact simple interest. We need to count the exact number of days. But take note, this is a leap year. So we'll be having the total number of years as January 8, 1990 to January 8, 1992. We have 2 years plus we have 274 days. Take note, this is a leap year. 1992 is a leap year. What is the equivalent of 1 year? We have 366 days. So we'll be having the total number of years. This will be 2 plus 274 over 366. We have 2.7486 years. We have interest, go to the present amount, interest rate, number of interest period. What is our capital value? That is equal to 1,000. Multiplied by the rate, we have 0.10. The computed number of years is 2.7486. So the interest is now equal to, this is 1,000 times 0.10. We have 200, we have 274.86. So 74.86, we have letter B. That is our answer for problem number 2. Okay, so next we have compound interest. So for compound interest, how to compute for the, we have several equations. First, we have the future amount. Okay, future amount is equal to the present amount multiplied by 1 plus I raised to the number of interest period. So we have several ways of compounding, or several types of compounding. So we may use I is equal to J, the nominal rate of interest divided by the number of compounding period. So we have I is the same as the effective rate, the same as compounded annually. If it is compounded annually, so we may use I if it is the effective rate, or if it is compounded annually. Then we have several types of compounding. We have the value of M is equal to 4 if it is quarterly. The value of M is equal to 2 if it is semi-annually. We have the value of M is equal to 12 if it is, we have monthly. So those are the common types of compounding. We have monthly, semi-annually, or quarterly. So we may expand this equation. That is, the future amount is equal to the present amount, just in case that the compounding is not effective rate, you're not using effective rate, or it is not compounded annually. So we have the future amount is equal to the present amount, 1 plus, is equivalent of the I, is the same as the nominal rate divided by M raised to N. So for N years, you have several number of compounding. So multiplied by M. So how to compute for the equivalent interest? Interest equal to future amount minus the present amount. Okay? So let's have an example. So our next example, what interest rate compounded quarterly is equivalent to 10% compounded semi-annually. So here in compound interest, you can convert one compound interest into another form or another types of compounding. So for example, you have that quarterly can be converted to semi-annually. So we call those terms as equivalent rates. So equivalent rates, that is, we have 1 plus I sub 1 raised to M1 equal to 1 plus I sub 2 raised to M sub 2. So if you can have it quarterly, then you can have it as semi-annually. So this is the same as 1 plus, if we have a compounding other than compounded annually, that is 1 plus J over M raised to M sub 1, this is J sub 1, M sub 1, equal to 1 plus the J sub 2 divided by M sub 2 raised to M sub 2. So we are doing, we have to convert 10%. 10% semi-annually. So let's say this is our J sub 1 is equal to 10%, 10% semi-annually. So 10% semi-annually is the value of M. If it is semi-annually, we have 2. Then we are looking for J sub 2, which is, supposedly this is quarterly. Alright, then we have the value of m sub 2. If it is quarterly, the value of m is equal to, we have 4. And so let us compute for the equivalent. Okay, so we have, this is 1 plus, what is our j sub 1? 0.10. This is compounded semi-annually, raised to 2 is equal to 1 plus, we are looking for a nominal rate, j sub 2, compounded quarterly, over 4 raised to 4. So what is the equivalent of this nominal rate, which is quarterly? So we have, let's say we go to 9.878%. So 9.878%, or we have, in our choices, we have letter A, that is equal to 9.88%. So this is equivalent rates. Okay, so our next example. So at the birth of a child, what amount should his father invest in order to provide the child with 25,000 pesos at the age of 21 years if money earns for entry 8% compounded quarterly. So basically, based on the question, what amount should his father invest? We are looking for the present amount. And the 25,000 pesos at the age of 21 years, that is the future amount. So we have the future amount with the present amount multiplied by 1 plus I raised to n. This is if it is compounded annually, wherein m is equal to 1. But since this is compounded quarterly, the future amount is to the present amount, the expanded form, we have 1 plus the nominal rate over m raised to n times m. So as compute for the present amount, we have the future amount is equal to 25,000 pesos equal to the present amount. This is multiplied by 1 plus the nominal rate. So by the way, what's the equivalent of the nominal rate? What is the value of 4 and 3/8? It is equal to the same as 4.375%. So we have, again, we have 25,000 equal to the present amount, 1 plus, we have, this is 0.04375. It is compounded quarterly, so if it is compounded quarterly, the value of m is equal to 4. So this is divided by 4, raised to how many years? We have 21 years. So we have 21 years. Each year, we have 4 quarters. So we need to multiply 4. Okay, so we are looking for the present amount. So we have the value of the present amount is equal to 10,000, 25.32. So 10,000, 25.32. So in our choices, we have letter A. So in order for that child to receive 25,000 pesos at the age of 21 years, the father must deposit 10,000, 25.32 pesos at present. That's our number 4 example. Okay, so our next example. So an investment of 8,250.5 increases by 10,200.5 if invested at 7% compounded quarterly. So find the term of investment in number of years. So usually we have the term investment, that is a present amount. So what is that value? The 10,200.5. As you can see here, the term increases by is used. So we have, that is the same as the interest. Increases by, that is the value added to 8,250. So it's an interest of 10,200.5. So how to compute for the future amount? Future amounts for the present amount plus the interest. So future amounts for the present amount, 8,250.5 plus the interest increases by 10,200.5. So this is an interest 10,200.5. So we're having a future amount equal to, this is equal to 18,451. So this is the value of the future amount. So we have the future amounts go to the present amount multiplied by 1 plus I raised to n. So again, it is compounded quarterly. Let us expand the equation. Future amounts to the present amount multiplied by 1 plus, we have j over m raised to m times n, or n times n. Anyway, pareho lang naman yun. Okay, so we have the future amount of 18,451. What is our present amount? It's equal to 8,250.5. This is multiplied by 1 plus our nominal rate, that's equal to 0.07 compounded quarterly over 4. This is raised to, we're looking for the number of years. Each year has 4 quarters. So you need to multiply it by, multiplied by 4. So let's compute for the number of years. So again, while I'm using the Canon F-789 SGA, so again, it is the same. It has the same function as the 570 of Casio, 570 S Plus, which has the function of ship solve or ship count, which is allowed on our civil engineering board exam. How many seconds will it take to solve for that value? We have 11.598 years. So in our choices, the nearest value we have letter B, we have 11.6. We proceed to the next topic. This is annuity. So annuity are a series of periodic payments made on regular intervals of time. So what is important if you are doing annuity, we should know on what period is the location of the future amount and the present amount. So basically, the location of the present amount will be always at time is equal to 0, and the future amount is on the last payment. Okay, the same time as the last payment. So as you can see, how many payments do we have here? The number of payments is we have 4. This first payment will have a 3 interest period, 3, for example, 3 years. Okay, the second one will have 2 years, and the third one will have 1 year. Okay, as you can see, the last payment will not receive any interest. Okay, since the future amount will be on the last payment. How do we compute for the future amount? So we have the future amount is equal to, that is the last payment, A, plus, how about this second to the last, that is multiplied by 1 plus I. Okay, it has a 1 compound, 1 interest period, then plus, how about this one? Second to the last. That is the annuity multiplied by 1 plus I. How many interest periods? We have 2. Okay, plus, okay, so as you can see, we have 4 payments. But the last payment will have only 3 interest periods. So we may conclude that is the first payment will have a value a 1 plus I raised to n. We have 4 payments, but the first payment will have only 3 interest periods, so that will be n minus 1. So that's how we compute for the future amount manually. So all we have to do now here is multiply both sides of the equation by this factor. We have the 1 plus I. What will be the result if we have to multiply 1 plus I on both sides? This is the future amount multiplied by 1 plus I is equal to, this annuity will be A, 1 plus I, this will be plus A, 1 plus I raised to, okay, so you had the exponents, that will be 2 plus A, divided by 1 plus I raised to 3, and so on, plus, we have the annuity, this is multiplied by 1 plus I, what will be the exponent? If you have the same base, all you have to do is add the exponents. We have n minus 1 plus 1 is the same as n. Alright, then from the original equation, we have the future amount is equal to A plus A 1 plus I raised to 1 plus A 1 plus I raised to 2 and so on up to A multiplied by 1 plus I raised to n minus 1. So this is the original equation. Then all we have to do is subtract these two equations. So what will be the, what are the remaining terms? We have the future amount, this is multiplied by 1 plus I minus, the future amount will be equal to, so we may cancel this one. What are these terms? Actually, we have supposedly, yes, so 3 and so on. So, supposedly we have these terms. Okay, as you can see, if we are to write every terms up to n, so this is the same as A, 1 plus, I raised to 3, and so on. So, what will be the term just before I plus A, divided by 1 plus I raised to n minus 1. Alright, so what is the term just before? Let me cancel these terms. What will be the term just before A 1 plus I raised to n? So let's say the term just before, what is the term just before n? That will be the same as A 1 plus I raised to n minus 1. The term before n is n minus 1. So that's why we are cancelling these terms. So the remaining terms on the right side, that is, we have this term, that is the annuity multiplied by 1 plus I raised to n minus the remaining term on this equation will be the annuity. Alright, then we are to simplify. This is the future amount multiplied by 1 plus I. We factor out f. This is f multiplied by 1 plus I minus 1. We factor out the annuity A. This is multiplied by 1 plus I raised to n minus 1. So we have f multiplied by I is now equal to the annuity I multiplied by 1 plus I raised to n minus 1. So computing for the equivalent of the future amount, that will be equal to the annuity, this is multiplied by 1 plus I raised to n minus 1 divided by I. So this is our formula in computing the future amount of an ordinary annuity. How do we compute for the present amount? Okay, how to compute for the present amount? So in computing the present amount, we go back to the equations of ordinary compound. What is the future amount of an ordinary compound? We have the future amount for the present amount 1 plus I raised to n. So present amount will be equal to the future amount. This is divided by 1 plus I raised to n. All we have to do is we have to use the future amount of annuity in this equation. So by substitution, we have the present amount is equal to equivalent of the future amount is the annuity. This is multiplied by 1 plus I raised to n minus 1. This is divided by I all over Okay, 1 plus I raised to n. So we'll be having the equivalent of the present amount as the annuity. This is multiplied by 1 plus I raised to n minus 1. I divide by I, 1 plus I raised to n. So this will be our equation for the present amount. But we can further simplify this one. So we can further simplify the equivalent of the present amount. We have annuity, so we may separate the fractions. We have this is 1 plus I raised to n. It's the first term on the numerator, I, divided by 1 plus I raised to n. Minus, that is 1 divided by I, 1 plus I raised to n. Okay, so as you can see here, we may cancel these terms. We have the present amount, we have now the annuity, this is multiplied by cancelling this one. So the remaining denominator will be I, or the rate of interest. That is 1 all over I. So we may bring this up, this term, 1 plus I raised to n, so bring it to the numerator. So this is minus 1 plus I, to bring it in the numerator, or we'll put the negative sign on its exponent, and the remaining denominator will be I. So this is another equation for the present amount of an annuity. That is the annuity called annuity multiplied by the quantity 1 minus 1 plus I raised to negative n over I. So let's have an example. So let's have our first example for annuity. So what is the present value of a 3-year annuity paying 3,000 pesos at the end of each year with interest of 8% compounded annually? So these are the given. So we are looking for the present value. Okay, kindly observe this one. If you are solving for annuity, can you observe the mode of payment and the mode of interest? So if there's no, they should have the same mode. So if the payment is done annually, the applied rate should be compounded annually. Okay? So we are looking for the present amount. Present amount is equal to the annuity multiplied by 1 minus. We have 1 plus I raised to negative n. This is divided by the interest rate. So we are looking for the present amount. The annual payment is equal to 3,000. This is multiplied by 1 minus 1 plus 0.08, good for 3 years. This is negative 3, divided by 0.08. So we are looking for the present amount. So this is an ordinary annuity. So the type of annuity is ordinary annuity since the payment is done at the end of each period. So we have a present amount equal to 7,731.29. 7,731.29. So on our choices, we have letter C, that is 7,731.3. Proceed to our next example. So a man loans 187,000 pesos from a bank with interest at 6% compounded quarterly. He agrees to pay his obligations by paying 8 equal annual payments, the first being due at the end of 10 years. If the payment will be done late, so as you can see, the first being due at the end of 10 years, this is an example of a deferred annuity, which means payments are done on later years. So find the annual payments. So you have here a rate of interest given as quarterly, but the mode of payment is annually. So we need to fix this one. We need to convert. They should have the same mode. Take note, the rate will adjust to the payment. So we have 8 annual payments. If we are to count 1, 2, 3, 4, 5, 6, 7, 8, that is the 8 annual payments, which means The payment should end on the 17th year. Okay? So we need to convert first the 6%. We need the rate 6% compounded quarterly to annually by equivalent rates. So let's say this is I1. If it is compounded annually, that is the same as the effective rate of interest, since the value of M is simply equal to 1. Let's say we have the J sub 2 is equal to 6%. This is given as quarterly. Okay, so if it is quarterly, the value of M is the same as 4. Okay, so by equivalent rates last time, we have 1 plus I1 raised to M1 is equal to 1 plus I sub 2 raised to M sub 2. So why do we need to convert? Again, the payment is annually. Okay, you should use a rate that is also compounded annually. So we having, this is 1 plus I sub 1 raised to 1 is equal to 1 plus, we have 0.06. This is now divided by 4, compounded quarterly raised to 4. By computing for the equivalent rate compounded annually. So we're having a value of, we have I is equal to 0 or in percent. It is the same as 136%. This is already compounded annually. That will match the mode of payment. So how do we compute for the annual payment? Okay, so for deferred annuity, you may bring all values to the present, or you may bring all values to the future. So we have an equation. The future amount of payments should be equal to the future amount of the debt. So again, where can we find the future amount of annuities? It will be on the last payment. That will be the future amount of the annuity. We may bring this present amount to the future. So as an ordinary compound for a period of 17 years. In the form of ordinary compound, since 187,000 pesos is a one-time payment, it is not an annuity. We have the future amount is equal to the present amount 1 plus I raised to n. Alright, this is for an ordinary compound. So we have, what is the future amount of the payment? It is the form of annuity. It's the annuity multiplied by 1 plus I raised to n minus 1 divided by I. That's the future amount of the annuities. How about the future amount of the 187 pesos one-time payment? That is the present amount. Since it is compounded quarterly, you may apply this 6% compounded quarterly since it is not an annuity. Okay? So we expand that. That's the same as the 1 plus j over m raised to m times n. If you can recall the equations, our equation for the future amount of ordinary compound. We have the annuity. This is multiplied by 1 plus. We should use this rate annually since that is an annual payment for the annuity. We have 0.06136. This is good for 8 payments. Minus 1 divided by 0.06136. And it's now equal to that value, 187,000, the one-time payment. We multiply by 1 plus 0.06 compounded quarterly over 4 raised to 17. This is 17 years. 1 year of that 17 years has 4 quarters. So we multiply it by 4. So what will be the value of the annual payment? We have a value of 51,000. $747.32. Okay, 51,747.32. So let's check if we have that value. Our nearest value we have letter A, that is 51,746.7. So maybe from the problem, the maker of the problem uses another number of decimal places. I only use 5.06136. But our answer for this one will be the nearest value, letter A. Okay, so before we proceed to our next example, let us discuss the difference between an ordinary annuity and an annuity due. So if you say ordinary annuity, the payments will be done, or the payments are done at the end of each period. So how do we compute for its future amount? Future amount is the annuity multiplied by 1 plus I raised to n minus 1. This is divided by I. This is for ordinary annuity. While for annuity due, the payments are done at the start. If we have the words start or the terms of the beginning, if the payment is done at the start or the beginning of every period, it is an annuity due. So as you can see here, we have three payments, the same as this. Where do we find the future amount? It is on the last payment, and the present amount is always at 0. The same with this ordinary annuity. The present amount is on 0. How about the future amount? The future amount will be on the third. Alright? So we'll be having a value, the future amount of the three payments on the last payment at 2, for example. But we'll be having one interest period. Okay, up to the end of the third year. Just an additional one interest period. So for annuity due, the future amount is called the annuity multiplied by 1 plus I raised to n minus 1 divided by I. But since we have one more period to earn an interest, that is multiplied by 1 plus I. So that will be the equation for annuity due. So let's have an example. So our next example, we have a farmer bought a tractor costing 25,000 pesos. That will be our present amount in 10 semi-annual payments. So 10 semi-annuals is the same as 5 years. And the value of number of compounding is 2. So 2 times 5 is 10. So if the rate of interest is 26% compounded semi-annually, determine the amount of each installment. So we don't have a problem here since our payment will be done semi-annually and the given rate is semi-annual. We don't need to convert the rates. So we are looking for the payment. The given value is a present amount. Present amount is called the annuity. This is multiplied by 1 minus 1 plus I raised to n, a negative n divided by I. But since as you can see, we use the term beginning. So if it is a beginning, this is an example of an annuity due. Alright, so if we have an annuity due, we have an additional multiplier, 1 plus, the 1 plus I. We may expand this equation as the present amount called the annuity, multiplied by 1 plus, 1 minus. This is 1 minus 1 plus the j over m, I raised to m times n, divided by j over m. If it is an annuity due, we have a multiplier of j over 1 plus j over m for annuity due. So you have the present amount, this is equal to 25,000 equal to the annuity. This is multiplied by 1 minus. We have the value 1 plus. The given rate is 0.26. It is compounded semi-annually over 2 raised to, we can use 10 semi-annuals or 5 times 2. That is the same as 10 semi-annuals. So raised to negative 10, I divide by 0.26 over 2, compounded semi-annually. If it is annuity due, we have an additional multiplier of 1 plus I, or the J over M. 0.26 compounded semi-annually. So let's compute for the value of the installments. So we have 4,000. It's equal to 4,077.20. 4,077.20. We have, so in our choices, we have letter B. Okay, next example. So an investment of 480 pesos is made at the beginning of each 6 months for 12 years and 6 months. So the payment was made every 6 months. That is the same as semi-annual. So what is the amount of investments at the end of the term if the interest rate is 3.5% compounded semi-annually? So we don't have a problem. Okay, the mode of payment is the same as the mode of rate. So we don't need to use the equivalent rates for conversion. So the period is 12 years and 6 months. That is the same as 12.5 years semi-annually, M is equal to 2. So as you can see, we use again the term beginning. If it is a beginning, this is a case of annuity due. So we are looking for the future amount of this problem. We have the future amount is equal to the annuity. This is multiplied by 1 plus I raised to n minus 1. This is divided by I. Okay, if it is annuity due, we have an additional 1 cycle of interest period. So we have it. The future amount is equal to annuity due, or the amount of the annuity is equal to 480 pesos. This is multiplied by 1 plus, what is the nominal rate? That is equal to 0.035. It is compounded semi-annually divided by 2. So the period of years, we have 12.5. This is 12.5 years. So we need to multiply it by 2 since the payment is done semi-annually. Minus 1. This is minus 1 all over the rate, nominal rate 0.035, compounded semi-annually. So again, if it is annuity due, we have an additional multiplier. That is the 1 plus the nominal rate 0.035. This is divided by 2. So we are looking for the future amount. That will be equal to 15,153.81. 15,153.81. So in our choices, we have letter B. So we proceed to perpetuity. So if we say perpetuity, we are paying annuity. That is the same as a series of periodic payments, but your period is up to infinity. We don't know what exactly, how many years or how many months you are going to pay. So you may consider a series of periodic payments as a perpetuity if you are to pay it for example, more than 50 years or more than, yes, for a very long period of time. So since it is up to infinity, we cannot determine the value of its future amount. We can only determine the equivalent of its present amount, which is basically the annuity divided by the effective rate of interest. So for other types of compounding, we have the annuity that is divided by the nominal rate divided by the number of compounding period. So for example, we have problem number 10. I find the present value of perpetuity 15,000 pesos. So we have an annuity of 15,000 pesos. It is payable semi-annually. If money is worth 8% compounded quarterly, but the given rate, we have this is 8%, it is compounded quarterly. As you can see, we have a problem here. The mode of payment is not the same as the mode of rate. So what we have to do is, we have to use equivalent rates. We need to convert the rate quarterly to semi-annual, since that is the mode of payment. So let's say for semi-annual, this is J1. So let's say this is for semi-annual. For semi-annual, the value of our number of compounding will be 2. Let's say we have the given 8%, that will be our J sub 2, which is quarterly. And the value of M, or the number of compounding period for quarterly, M sub 2 will be equal to, we have, this is 4. So by equivalent rates, this is the same as 1 plus I sub 1 raised to M1 equal to 1 plus the I sub 2 raised to M sub 2. Or the equivalent expanded form, this is the same as 1 plus J sub 1 over M sub 1 raised to M1 equal to 1 plus J sub 2 divided by M sub 2 raised to M sub 2. So we are looking for the rate semi-annual. So that will be equal to 1 plus J sub 1 over, we have 2, this is raised to 2, equal to 1 plus, we have J sub 2 that's given as 0.08, it is compounded quarterly over 4 raised to 4. So what will be our rate? J sub 1 now in terms of semi-annual. We have J sub 1 semi-annually. And we have, this is 8.08% semi-annually. We are going to use this one since your payment is semi-annual. We have the present amount is equal to the annuity divided by I. Present amount is the same as the annuity divided by the nominal rate divided by the number of compounding period. So you have present amount, this is 15,000 divided by the computed rate semi-annually 0.0808. Semi-annual, again, this is the value of M. If it is semi-annual, this is divided by 2. So the present amount will be equal to, we have 15,000 divided by 0.0808 over 2. So we'll be having a value of 371,287.13. 371,287.13. So let us check. Okay, we have letter C, that is equal to 371,287.13. So that's our example for perpetuity.